Okay, limiting reactant problems. Let me start off by saying these are some of the most difficult problems that we will have to solve all year. So if you don't quite get it at first, that's okay. It's just one of those skills that you really have to practice to get good at. Okay, so the first step for all stoichiometry problems, all limiting reactant problems, is to double check and make sure you have a balanced chemical equation, because sometimes you will have one, sometimes you won't. This one is already balanced. And the first question we are asked is to figure out how many grams of the product are produced. We're only given a very small amount of information, and it actually helps me to just kind of fill this information in above the equation. We're starting with 4.1 grams of CR, and it reacts with 9.3 grams of Cl2, and we are asked to find how many grams of CrCl3 are produced. So I'm just going to put an X there representing my unknown. The first thing I'm going to do is do a mass to moles to mass calculation, starting with just my first reactant. Doesn't matter, you can start with whichever one, and figure out if I were to use my full 4.1 grams here, how many grams of the product could I make? Then I'm going to do the exact same thing, go from mass to mass with my second reactant and compare those two values, and I'm going to have to pick the smaller one, and I'll show you why in just a minute. Okay, so I'm going to start off by writing down the 4.1 grams of CR that we start with, and the first thing I'm going to do is just convert to moles. This first piece should look very familiar. All I'm doing is dividing by the molar mass. And I know what you're going to think. You're thinking to yourself, where in the world did that 52 come from? Well, my friend, that is the mass off the periodic table. So check your periodic table, make sure I'm filling that in correctly. Then I'm going to follow my units. Since I have moles of CR up top, I'm going to have moles of CR down below. That way they'll cancel out. And I'm going to look at my mole ratios. So I'm going to put mole CR here. And I want to get to grams of CrCl3. I can't yet. I have to first swing through moles, because I can look at my mole ratios. Where do I go to fill in my mole ratios? I have to look at the coefficients in my balanced chemical equation. So when I glance at this quickly, I see a 2-to-2 ratio. Yes, you can simplify and put 1-to-1. Won't change your answer. And then I'm going to continue to follow my units. If I have moles of CrCl3 up top, I have to have moles down below to cancel out. So that's exactly what I'm going to put here. CrCl3. And then I'm going to convert back to grams. So in this case, you'll end up multiplying by the molar mass. So where did I get 157 grams? That is the molar mass off the periodic table. Okay, so now we're all set. Our units are going to cancel all the way through, which is wonderful, and we'll be left with grams of our product, which is what we want to know. We want to see. If I were to use all 4.1 grams of my reactant, what would be the maximum amount of product I could make? Perfect. So how do I solve this bad boy? Well, it's actually really simple. If you multiply everything across the top, punch in your calculator 4.1 times 1 times 2 times 157, and then continue to punch in, whoops, I forgot one mole down there, and then continue to divide by everything in the denominator. Hit divide by 52, hit divide by 2, hit divide by 1, and you should end up with an answer somewhere around 12.4 grams of our product. Awesome. Now I'm going to do the exact same thing, but starting with my other reactant. I'm going to go from mass to moles to mass and figure out what's the maximum amount of product I could make if I used all 9.3 grams of Cl2. So I'm going to start off the same way, 9.3 grams Cl2, and just simply convert to moles. So 1 mole up top, the molar mass should be 70 grams. Where did I get the 70 grams? That's the molar mass of Cl2 off the periodic table. Follow my units. I know I'm going to have moles of Cl2 down below, and I'm going to have moles of my product up top. Perfect. Where do I go to find my mole ratios? I'm going to go back to my balanced chemical equation and check out the coefficients. This one looks like it's a 3:2 ratio. So I'm going to put 3 down below, 2 up top. And then that last step is going to look identical to what we did up top there for our first reactant. We're just going to convert back from moles of our product to grams of our product. That way we can compare our values in grams, and that will be useful for us. So 1 mole goes down below. And again, how do I solve this? You're going to multiply by everything up top. Punch in your calculator 9.3 times 1 times 2 times 157. Then hit divide by. You'll divide by everything in the denominator. Divide by 70, divide by 3, divide by 1. And you should get something along the lines of 13.9 grams of my product. Perfect. Now I've got two values here that I can compare, and they're both in grams. I'm always going to have to pick the smaller value. Reason being is because I'm running out of that product or that reactant at that time. So my answer to number 1 will be the smaller value of the two. What is it, 12.4? 12.4 grams of my product. And this, these two calculations you just did actually will help you answer number 2 as well. You're picking the smaller number here, the smaller value of grams of product, because you're running out of this reactant. After you use all 4.1 grams of CR, you can only make 12.4 grams of your product and not one speck more. Why? Because you ran out of CR. If you were to look at your second calculation, this is actually showing you you're going to end up with excess or extra Cl2 left over because you have enough Cl2 to make more grams of the product. You can't make that much. So let's go ahead and answer number 2. My limiting reactant here is going to be Cr, so I'll just put limiting Cr, and that means in excess. We had Cl2. Perfect. Okay, number 3 is another doozy here. It says how much of the excess reactant is left over. Oh my goodness. Okay, so how are we going to do this? I'm actually going to do another mass to moles to moles to mass calculation, but this time I'm going to start with my theoretical yield of my product and connect it back to mass of my excess reactant here. So this is kind of another mass to moles to mass calculation, and I'm going to see how much mass of Cl2 I would use if I were to, in theory, produce the full 12.4 grams of my product. So let's dive on in here. I'm going to start with 12.4 grams of my product, CrCl3, and just simply convert to moles. This first step should be very familiar. 157 we already know is the molar mass, so that goes down below this time. And now I'm going to look at my mole ratios. Moles of my product are up top in the numerator, so I know moles of my product have to match down below in my denominator to cancel, so I'm going to put moles CrCl3 here. And then moles of chlorine this time. I want to see how many grams I'll end up using of that. Where do I go to find my mole ratios? Well, for this one, it looks like it's going to be a 2 up top and a 3 up top and a 2 down below. So let's go ahead and fill those in. So we'll have 3 to 2 ratio, and then convert back to grams. If I have moles of Cl2 here, I have to have moles of Cl2 down below to cancel. So that's what I'm going to do. And then grams, Cl2 will go up top. 70 grams, where did I get that number? That's right off the periodic table. How do I solve this equation? I'm going to multiply 12.4 times 1 times 3 times 70. Then I'm going to divide by 157, divide by 2, divide by 1, and you should get about 8.3 grams Cl2. And I'm going to put the word used here, because that's what this is telling us, and that really ends up helping me out. This whole equation that we just crunched out here tells me if I were to make the full theoretical yield of my product, how many grams of Cl2 would I have to use, which is great. That's useful information to me. I haven't answered number 3 yet, but I'm close. How many grams of chlorine did we start with? Look back at what the problem originally gave us. The problem originally gave us 9.3 grams to start with, and we just calculated to make our theoretical yield of our product, we will have to use 8.3 grams. So all I'm going to do is subtract the 2, and you should end up with 1 gram of Cl2 left over. So that's a little piece that students tend to forget. You got to do the subtraction. So 1 gram Cl2 left over. Okay, and last but not least, this is our final step here. I'm going to box it in up here on the top because I'm running out of space. Find the percent yield, number 4 says, if actual yield is 10.2 grams of CrCl3. Okay, cool. Well, we already know what our theoretical yield is. I answered that for the first question. We got that. And then actual yield is given in problem 4. So if you remember, percent yield is equal to actual over theoretical. So I'm just going to plug in some numbers here. Actual was 10.2. That was given in problem 4. Our theoretical is what we calculated to be the max amount produced. So I'm going to put 12.4 here. I'm going to divide and then, running out of space, multiply by 100. You should end up with somewhere around 82.3% for your percent yield. And what that's telling us is whoever performed this reaction obtained 82.3% of their total products that they could have made. So not terrible, but if I was running a business and my employees said, oh, we're only running at 82% efficiency, I would be in there the next day saying, what can we do to streamline this process to get more products obtained? Okay, again, these are very difficult problems. They're long, they're drawn out. You have to go from mass to moles to mass, not once, not twice, but 3 times here. And if you guys have Lestort next year, he'll probably cut you off and stop at moles and have you compare your values at moles. There's quite a few different ways that you can tackle these problems. I just prefer going from mass to moles to moles to mass. You can really get the right answer either way. The way that I suggest you study is to just go online or Google or look in your textbook, whatever you guys have at your resources, and just find more products or find more questions like this. See if you can answer them. It's just one of those skills that you really have to practice. You can't just do 1 or 2 problems and think you got it. You really have to practice multiple times. So I hope this video helped. Good luck.